Hi and welcome to another presentation of Tech for Everyone, free training in tech provided by eTrain. Today's presentation is all about cooling. What's used in a PC to keep the temperature down? And what is meant by passive and active cooling? Let's find out. Well, a PC is a lot like any electrical device. It produces some heat. Now, this is because of current flow through electronic components. Now, if the temperature is too high, particularly in a PC or any of its components, they may shut down or fail completely. CPUs, graphics cards, and even some types of memory require cooling. Our first type of cooling device is a very simple one. It's called a heatsink. It's basically a large block of metal with fins. You can see the fins in the photograph. Now, these increase the surface area to remove heat. Basically, the more surface area we have, the more heat can be removed. The heatsink itself is attached to the chip with thermal compound. Now, that ensures good heat transfer by conduction, and then the heat's going to move off to the air by convection. Good airflow is therefore very essential in a heatsink. Now, thermal compound is not just a glue. It contains substances that ensure not only is the heatsink going to be attached to the chip, but heat is going to be transferred to the heatsink. We apply a very small amount to something like a CPU to ensure that good thermal contact is made, and I can't stress that enough. It's very, very important. A lot of modern PCs don't just use a heatsink anymore. We use a fan heatsink assembly. In fact, on most CPUs, a heatsink is used along with a fan. The fan increases airflow to help remove the heat more effectively. The speed of the fan itself can be controlled on temperature sensors that we find on the board itself. A lot of high-end graphics cards also use a fan heatsink. In this photograph, you can just make out the fan, but you can't quite see the heatsink, but I can assure you it's definitely there. The fact that a fan spins tells us that it's going to create some noise, which is one of the biggest problems when using fans. There have been lots of improvements with fans on modern PCs, but there's still a noise issue. While we're talking about this, we also do need to say something about passive and active cooling. Passive does not involve a fan or a pump, whereas active uses one of the above or sometimes both. So, a heatsink is an example of a passive cooling device and a fan an active. Now, we're going to use that knowledge and see if we can answer a question at the end of this slide. We're looking at a heat pipe. It's basically a sealed tube containing a coolant. Evaporation close to the heat source produces cooling, and the vapor turns back into a liquid at a cooler part of the pipe. It has no moving parts, so it is very, very quiet indeed. Now, is that active or passive? Well, if you said passive, you'd be absolutely right because there are no moving parts there at all. If we want a more advanced form of cooling, we could go with a liquid cooling system. Here, coolant is pumped around and over the CPU. In fact, in this photograph, you'll make out the pump towards the lower left there. Heat is transferred and removed through with the help of a radiator, a bit like the old radiator on a refrigerator. Now, a pump is much quieter than a fan, and in fact, heat is removed more effectively and efficiently than the fan and heatsink assembly. The only problem with this system is that it is expensive and sometimes hard to maintain. So, is that active or passive? Well, if you said active, you'd be absolutely right, because the pump moves the coolant around. So, in summary, cooling is needed to keep PC components at the correct temperature. If we don't keep them at the correct temperature, they will just shut down or stop working entirely. Cooling can be active, such as in a fan, passive, such as in a heatsink. And we attach our cooling devices generally with thermal compound to ensure a good flow of heat from the chip to the heatsink. I want to thank you for listening to this presentation of Tech for Everyone. A free PDF study guide is available at t2g.net/eTrain. Thank you for listening, and goodbye.